Hello friends, today I'm going to show you how to solve problems in integration by a method which is called integration by parts. Okay, as we know from calculus part 1 differentiation, for the differentiation of products ddx of a product of two functions u and v, where u and v are functions of x. We know that it is the first function with the differential multiplied by the differentiation of the second function plus the second function multiplied by the differentiation of the first function. So it is u dv by dx plus v du by dx. Now if we integrate both the sides, since differentiation is the reverse of integration, so now if we again integrate this function, we are going to get back uv. So let's integrate both the sides. So by integrating both the sides, we will get integration of uv ddx of uv, we will get back uv again. And if we integrate u with dv dx with respect to dx, we will get integration of u with respect to dv and integration of v with respect to du. So now if we take this function, integration of u with respect to dv on one side, it will be uv minus v integration of v du. This formula forms the basis for solving problems on integration by parts. Okay, so we will be taking a few examples to show this method and things will get clear. Before we start solving examples in integration by parts, please note that this formula is used to calculate integration of a product of functions where one of the functions is at least a sine function or a cos function or something to the power of a function or a logarithm function. Okay, so let's now solve some examples to make things more clear. So in this example, integration of x plus 1 sine x dx. One of the functions is a sine function. So how do we solve such a integration? So what we will do, we will say the first part u is equal to x plus 1. That means this is the first part. This is the first part. And the second part is we put dv is equal to sine of x dx. So this is the second part. Okay, this is the second part. So now we will differentiate the first part. The first part we'll differentiate the first part. Okay, so we get here du by dx is equal to differential of x is 1. This implies that du will be equal to dx, and we will integrate this part, we will integrate the second part, we will integrate. Okay, so if we integrate this part, it will be integration of dv will be integration of sine x with respect to x. Okay, so we will get integration of dv, we'll get back the function v, and integration of sine x, as we know, is minus cosine of x. Okay, so now we got u equal to x plus 1, v equal to minus cos x. Now we just have to plug in all the values in the previous formula. What was the formula? Integration of u dv is equal to uv minus integration of v du. Okay, so integration of u, what is u? X plus 1. What is dv? Sine of x dx. Okay, this is equal to u. What is u? It is x plus 1. What is v? We got here as minus cosine of x, minus integration of v. What is v? Minus cosine of x. And du. What is du from here? Du is equal to dx. So we had here. So this is minus cosine of x. So this nothing is there already. It is integration has been done for this. Nothing to be done in this part. So here minus and minus becomes plus, and integration of minus of cosine x is plus sine of x. So we get back here sine x and we add the constant of integration. So, okay. Okay, let's take another example. Integration of x squared plus 2x cosine of x dx. So we will make this as the first part and this as the second part. So first part is u is equal to x squared plus 2x. The second part is dv is equal to cosine of x dx. Fine, let's differentiate this one. So du by dx is equal to 2x plus 2. Integrate this one. This will be differentiate and this will be integrating. So if we integrate this, we will get v equal to cosine of x is, we know it is sine of x. Okay. Now just plug it into the formula. So integration of u dv is equal to uv minus integration of v du. So this becomes x squared plus 2x cosine of x dx is equal to u. What is u? X squared plus 2x into v. What is v? Sine x minus integration of v. What is v? We got sine x. And what is du? Du is equal to 2x plus 2. 2x plus 2 dx. Here du is equal to 2x plus 2 into dx. And we add the constant of integration. Now again we see that this one is a product of sine of a function and an algebraic expression. So again this part we have to apply the same rule as we did here. So from here I'll take this as the first part, this as the first part and this as the second part. Okay, so we get here again u is equal to 2x plus 2 and dv is equal to sine of x dx. So what we get here, du is equal to, du by dx is 2. Du by dx is 2. So du will be equal to 2 of dx. Okay, here v is equal to integration of sine x is minus cosine of x. Okay, so again we apply the same formula now. Again u dv is equal to uv minus integration of v du. So we get here this part, we get this part here, integration of sine of x. Sine of x is sine of x into 2x plus 2 dx is equal to u. What is u here? 2x plus 2. 2x plus 2, v is minus cosine of x and minus integration of v du. What is integration of v du? Integration of v du is integration of v is minus cosine of x and du is twice dx. So this is twice of dx. So we get here minus 2x plus 2 of cosine of x, minus and minus becomes plus, or we can say minus cosine of x. The integration of minus cosine of x is sine of x plus c. Now since this plus c is already there, so we no need to add another constant here. So we'll just keep this, replace this by this expression. We will replace this by this expression. So the final expression here, if we see here, the final expression will become x squared plus 2x into sine x minus, instead of this expression we will add this expression. So minus and minus becomes plus. So it is 2x plus 2 cosine of x, okay, minus 2 sine x. And finally we add the minus and minus becomes a plus again. Minus and minus becomes a plus. So This is minus, yes. So this is, sorry, this is plus sine x here. So this becomes a minus 2 sine of x. Okay, minus 2 sine x plus c. Okay, so this is the solving the, this is how you solve a problem having a cosine of x as one of the functions. In this example, you see it is an integration of ln of x dx. So here we will take the first function as and the second function as dx. So we'll take u is equal to ln of x. Okay, so du by dx, this is the first part, u is equal to ln of x. So du by dx is equal to, we know it is 1 by x. Okay, and the second part, that second part is dv is equal to dx. If we integrate both the sides, we get v is equal to x. So now integration of u dv is equal to uv minus integration of v du. So integration of u dv is, we get back the original expression, dx is equal to u is equal to ln of x. What is v equal to x? So it is multiplied by x minus integration of v. What is v here? X. And what is du here? Du is dx by x. Du is dx by x. This x and x cancels. So we are left, and we add the constant of integration as c. So we get here x, ln of x minus integration of dx is x. So this is how you solve a problem on integration having one of the functions as a logarithmic function. Okay, let's take another example. Integration of x, ln of x dx. So now again we will take the first part as u is equal to ln of x. The second part we will take as dv is equal to x dx. Okay, now differentiate the first part. So we get du by dx is 1 by x. Integrate the second part. So we get v is equal to x squared by 2. And plug in the values of v, u, etc. into the formula for integration by parts. So we get uv minus integration of v du. So here it is. What is u? Ln of x. What is v? X squared by 2. So we can write x squared by 2 before the ln of x. Okay. Minus integration of v. That means integration of x squared by 2. And we know du is equal to dx by x. So this is dx by x. So obviously this x and this x cancels off, and we add the constant of integration c. So nothing to do here. Now integration of, this is half integration of x of dx plus c. So we get x squared by 2 ln of x minus half into integration of x, you know, is x squared by 2 plus c. So we can write it x squared by 2 minus x squared by 4 plus c. Okay. So that's all for today, and we will be taking some more examples in the next lecture to complete this integration by parts method for solving problems on integration. Thank you.